Hey everybody, Dr. A here, and in this video we're going to be exploring an example of axial loads. So let's take a look at what we're given. Here we're given this simple sentence, compute the reactions for the axially loaded bar. And we're given an illustration here. We have a bar that's fixed at its top, and that point is going to be point A, and it's subject to a uniformly distributed axial load of 2 pounds per inch. And at its free end, it has a 7-pound load applied right at the free end. And the bar is a total of 12 inches long. So let's go ahead and get started. We're going to start with writing solution. Then we're going to draw a free body diagram of the entire system. Okay, so we're going to say FBD of system. Now, what does that look like? Well, a free body diagram is just a diagram that shows all of the knowns and unknowns acting on a system with dimension lines. So here we have this bar that's 12 inches long, and the knowns are this 7-pound load at the end and this uniformly distributed axial load along its length of 2 pounds per inch. Now, what else is unknown? Well, at the fixed connection, how many unknowns do we have? Well, technically, we have 3 unknowns. Technically, we have an AY, we have an AX, and we have an MA, okay? But if you remember, for axially loaded systems that are pure axial loaded, we only really have one applicable equilibrium equation. And what is that? That's going to be sum of the forces along the longitudinal axis equals 0. In this particular problem, that's going to be sum of the forces in the y direction equals 0. Okay? And so if we just look at forces in the y direction, what do we have? Looking at this free body diagram, we have AY, and then we have minus 2 pounds per inch times 12 inches plus 7 pounds equals 0. Now, how did I come up with all of that? Well, again, we're looking at forces and everything in the long direction, in the y direction, okay? So the first thing I encounter is AY pointing up. That's why AY is positive here. Then I encounter this uniformly distributed axial load, 2 pounds per inch, and it's pointing down, and it's spread out over 12 inches. So I've got minus, because it's pointing down, 2 pounds per inch times 12 inches. And then at the very end, I have 7 pounds pointing up, so that's a positive 7 pounds. And so what I'm going to do is some pretty simple algebra here, and I'm going to rearrange this, and I'm going to end up with 24 minus 7, and so I'm going to get 17 pounds as my axial reaction. Okay, now that comes out positive, which means what? That means that that axial reaction is actually pointing upwards, okay? So it's pointing in the direction that I assumed in my free body diagram. So if you remember from your knowledge of statics, whenever you have an unknown reaction, you assume the direction of those unknown reactions. You perform the calculations with your equilibrium equations, just like we did here. And if your final answer comes out positive, that means that that reaction is pointing in the direction that you assumed. In this case, for us, we assumed AY was pointing up. Now, if you watched the previous video, you would have seen that the other 2 reactions, AX and MA, should be 0, okay? But why is that? So I'm going to go ahead and box in AY because that's really our answer. But let's go ahead and investigate why AX and MA are 0. Well, if you look at this free body diagram, if you say sum of the forces in the x direction equals 0, like we would in statics, what does AX become? Well, AX is just simply 0. And that's because there's nothing else acting in the horizontal direction. It's AX plus nothing, and so you get AX equals 0. Similarly, you can say sum of the moments about point A equals 0, like we would do in statics, and here we would get MA equals 0, because there's nothing else happening on this in this free body diagram that will generate a rotation, that's going to generate a moment. So MA is going to be 0. So when you know you have a pure axially loaded system, all you need to do is show sum of the forces along the longitudinal axis equals 0, and then that's your one applicable equilibrium equation, just like we talked about in the previous background video. So that's the conclusion of this example. If you found this helpful, please hit like and subscribe, and be on the lookout for other similar videos. Thanks for watching.